4.8 is about complex numbers. If you remember from lesson 4.7, if the discriminant turns out to be a negative number, there are no real solutions, but what you will have instead is complex solutions. So here are some examples. If we were to begin to solve this equation, we would subtract 32 on each side, which gives us negative 32. Divide by 2, which gives us negative 16. And then we take the square root. At this point, we begin to see that we have a problem because the square root of 16 is not a real number. We know that the square root of 16 equals 4 because 4 times 4 equals 16. We also know the answer is negative 4 because negative 4 times negative 4 also equals 16. But there's no way to make it equal a negative 16 because positive 4 times negative 4 is not the same number, which makes it not a square root. So to get around that problem, what we do is we take the square root of 16, which is 4, and then the square root of the negative is I. So we get plus or minus the square root of 4i. Okay, so you go ahead and do the next two problems here. Okay, this particular type of problem we can solve by using the quadratic formula. So we get x equals negative b, where b is negative 3. So negative 3 squared is 9, minus the square root of b squared, which will be 81, minus 4 times 2 times 5, divided by 2 times 2 is 4. 4 times 2 is 8, 8 times 5 is 40, so we get 81 minus 40, so we get the square root of 41, and so our solution is x equals 9 plus or minus square root 41 over 4. This is a real solution. On our second example here, if we do x equals negative b, so we get 1, plus or minus the square root of 1 squared is 1, minus 4 times 3 times 2, divided by 2 times a, which will give us 6. 4 times 3 times 2 is going to be 24. 1 minus 24 is negative 23. So now we're taking the square root of a negative number. So we end up with a complex solution where x equals 1 plus or minus the square root of the negative is I. And 23 doesn't come out to an integer, so we leave it as square root 23 over 6. So this is a complex solution. So what we have learned here is that the square root of negative 1 equals I, and since the square root of negative 1 equals I, then I squared must equal negative 1. So that's what we have here. The second one is a misprint. It should say the square root of negative 1 is I. So we can calculate some, we can simplify some square roots. So the square root of negative 18 can be simplified to the square root of I times 18 is 9 times 2. Well, actually, we don't want that to be an I. Let's change that. Negative 1 times 9 times 2. Square root of 9 is 3. Square root of negative 1 is I. And 2 is not a perfect square. So there's our solution. And you can put a plus and a minus on that. So you can calculate these other three. So in order to give the complex number some meaning, we would need to graph it and then find its absolute value. So When you graph a complex number, instead of having an x and a y axis, you have a real axis and then you have an imaginary axis. So the number -5 plus 3i would go left 5 and then up 3. So right about there, that would be the number -5, 3. So then to find the absolute value of a number is the distance from 0 So we're trying to find how far is it from our number to the origin. So to find that distance, you use the distance formula, which you may remember from geometry. The distance formula equals the square root of x minus x squared plus y minus y squared. So along this x-axis we have 5, and along the y-axis we have 3. So the distance is going to be 0 minus 5, which is 5. 5 squared is 25. And 0 minus 3 is 3. 3 squared is 9. So the distance would be the square root of 34. So the absolute value of -5 plus 3i is square root of 34. Here's one for you to try. So plot the point on the complex plane and then find the absolute value of that number. Actually, I'll do this one because we have 3 more on the next page. So the number 6i is going to go on the imaginary axis up 6. So we're going to be right about here. Since this is straight up from the origin, we know that the absolute value of 6i is going to be just 6. So absolute value of 6i equals 6. Here are 3 for you to try. And when you finish these, go on to part 2.